Imagine you're sitting in an airplane at 30,000 feet. Outside your window, the temperature is around -60 degrees Fahrenheit, and the air is so thin that you would lose consciousness in less than a minute. Inside the cabin, though, everything feels completely normal. You're breathing comfortably. The lights are on. 2 rows behind you, someone orders a coffee. But there's something most passengers never think about. The entire airplane around you is under enormous pressure, and that pressure is constantly trying to escape. Right now, it's pushing against the walls, the doors, the floor, and the window next to your head. Now imagine something even stranger. Imagine that the only thing preventing the aircraft from tearing open is the shape of that window. Because the reason airplane windows are round today is tied to one of the most important and tragic engineering lessons in aviation history. And it all began with a plane that looked perfectly safe. In the early 1950s, aviation was on the edge of a revolution. For decades, passenger planes had relied on propellers. Flights were slow, noisy, and limited in altitude. Crossing the Atlantic could take more than 12 hours. Then a British aircraft manufacturer introduced something extraordinary.
Ladies and gentlemen, the future of flight begins today.
The Havilland Comet. It was the world's first commercial jet airliner. For passengers, it felt like the future had arrived overnight. The Comet flew faster than any airliner before it. It cruised higher than the clouds and above most weather. Flights became smoother. Travel times dropped dramatically, and airlines rushed to buy it. Passengers loved it. For a moment, it seemed like aviation had taken a giant leap forward. Then something terrifying began to happen. Planes started falling out of the sky. In 1954, several Comet aircraft suddenly broke apart mid-air. Not during takeoff, not during landing, but while cruising peacefully at altitude. There were no explosions, no distress calls. Entire aircraft simply disintegrated in flight. Investigators were stunned. These airplanes were brand new, designed by some of the best engineers in the world. At first, authorities suspected sabotage, then turbulence, then pilot error. But none of those explanations fit the evidence. So, investigators did something unprecedented. They reconstructed the wreckage piece by piece. And slowly, a disturbing pattern began to appear. Nearly every fracture started in the same place, near the windows. To understand why, you need to understand how airplanes survive at high altitude. At cruising height, the air outside the aircraft is extremely thin. Humans cannot survive in it, so the cabin must be pressurized. Air is pumped inside the aircraft to create a breathable environment. But that pressurized air is constantly pushing outward against the fuselage. Imagine inflating a balloon. The more air you add, the more the surface stretches outward. An airplane experiences the same force, except instead of rubber, it relies on metal. Every time a plane climbs, the cabin pressurizes. Every time it lands, the pressure decreases again. This happens every single flight. Engineers call these pressurization cycles. And over time, repeated cycles can slowly weaken metal. But the Comet had a hidden flaw. Its windows were square. At first glance, square windows don't seem unusual. Buildings use them everywhere. But in engineering, sharp corners create something called stress concentration. When pressure spreads across a curved surface, it distributes evenly. But when pressure reaches a sharp corner, the force becomes concentrated into one tiny point. Like the crease in folded paper, the sharp corners of the Comet's windows created weak points where the metal could tear much more easily. Every pressurization cycle focused stress into those corners. Tiny cracks began forming in the metal. At first, they were microscopic, invisible. Eventually, one crack would reach a critical length. And when it did, the aircraft structure could fail catastrophically. To prove the theory, engineers performed one of the most famous investigations in aviation history. They placed an entire Comet fuselage inside a massive water tank. Then they repeatedly pressurized and depressurized it, simulating thousands of flights. Cycle after cycle, the metal endured the stress. Until finally something appeared. A crack. Exactly where investigators suspected. Right at the corner of a square window. With each additional cycle, the crack grew longer. Until the fuselage suddenly failed, just like the real accidents. The mystery was solved. The fix turned out to be surprisingly simple. Instead of square windows, engineers redesigned them to be rounded or oval. A curved shape spreads stress evenly around the frame. There are no sharp corners where pressure can concentrate. That small design change dramatically reduced the risk of structural cracks. From that moment on, aircraft design changed forever. Every commercial airplane built since then has used rounded windows. But the lesson didn't stop with airplanes. Engineers began applying the same principle everywhere. Submarines use rounded hatches. Spacecraft use curved openings. Because when materials experience repeated stress, small design choices can determine whether something lasts for decades or fails without warning. So, the next time you're sitting by the window on a flight, take a closer look at its shape. That small rounded frame next to your seat isn't just a design choice. It's a solution written in engineering history. A reminder that sometimes the difference between safety and disaster can be something as simple as a corner. This is Fact Factory. Breaks down the hidden logic behind everyday things. You see it, we explain it. If you want more stories about the surprising science and history behind the world around you, subscribe to our channel.